Good morning, everyone. We are the group TrivTech, consisting of team members Maria Cardigan, Brandon Nori, and myself, Shivam Prasad. Welcome to Project Insight. I will now hand it over to Maria to introduce our project.
Thank you, Shiv. Our project Insight addresses one of the main issues faced by the hearing impaired community, which is that there exists a large majority of the population who cannot understand sign language, and this puts a strain on their ability to communicate with each other. We plan to tackle this problem by developing a mobile application which facilitates image processing such that it can be used primarily by those who are not versed in sign language so they can understand those who rely on sign language. Now on to our target audience. Insight is geared toward individuals who do not understand sign language and are interested in learning sign language. Our app can also be helpful to the hearing impaired persons who depend on sign language as their means of communication. And lastly, businesses that would like to expand their user base can also benefit from this application. Let's talk goals and objectives. The Insight application mainly aims to provide a stylish, interactive translator that can break the language barrier between individuals who rely on sign language for communication and those who don't. As a result of this main objective, the application subsequently aids in providing a basic learning experience for users who want to learn about sign language. Now we will briefly go over the project timeline. Insight was developed over the course of 2 to 3 months. The first third involved brainstorming and the early stages of implementation. The next month and a half focused primarily on implementation, while the last month was spent making finishing touches and doing various tests, which we shall discuss shortly. Project Insight is an application that aids in the interpretation of sign language. Insight focuses on its design and superior hand sign recognition to provide the best sign language translation using holistic landmarks from detected hands rather than processing an image. Now on to Shiv for the architecture.
The architectural design shown below essentially mimics that of a model view controller application architecture, as our users would be expected to interact with the main view, which is constructed using XML to display our desired interfaces. Our Java controller acts as our main processor, determining the outcome of specific actions upon calls to the camera of the device. The controller will allow the camera to be accessed within the application. The resulting frames retrieved from the video being captured by the camera will then be used by the hand detection model and subsequently be processed to ascertain what said data means using the sign language recognition classification by the TF-Lite model within. Following on, in this diagram we see that the pixel coordinates are taken from any given frame and is passed through a hand detection model. This model will get holistic landmarks of key points within a hand and pass it to a convolutional neural network, which will use said key point mapper to a classification algorithm to make a prediction of what the detected landmarks most likely are. Our model was trained using a local database of manually collected landmarks of various signs. Note that our application takes advantage of the machine learning library TensorFlow and its lightweight TF-Lite model in order to use the GPU for machine learning models in a lightweight way which can be sustained by a mobile device. Lastly, the sequence diagram shown depicts the process of the main task of capturing a frame and translating any found hand signs. Created to ascertain the general flow of the system, it illustrates the beginning to the end of the activity, thus creating a better understanding of how to accomplish our main goal. Our team constructed some low-level prototypes which we could use through the implementation phase as a base model. Now, onto the live demonstration. Opening the application, you will see a sleek splash screen. After loading is done, a user will be brought to the home screen, at the bottom of which you can see navigable tabs which can take you through the main views of our application. On the home screen there lies a View Dictionary button which, when interacted with, will bring the user to a dictionary page which contains a collated list of all the relevant signs recognizable by our application. This page also has backward navigability. Now, navigating to the About page, you will find a brief project description as well as an explanation of features within the application. At the bottom of this scrollable list, you will find basic information on the developers. Finally, let's get into the meat of our application, the Translate tab, in which you are able to have your hand detected and any predicted sign prompted. As you can see, there are sleek animations and a button which allows the user to switch between the front and back cameras. You can also find a toggleable button for text-to-speech. Now, let's get into a real demonstration. How about we try signing hello? Using my left hand, you can see that I attempt the H sign and it's detected. Upon clicking the middle button, it's added to the main string. Now we do E with my right hand, showing that you can have multiple hands used. And let's do the rest with my front camera. L, L, O. As you can see, it's all been added, and now if I were to tap the main dialog box once again, it would repeat it to me as long as the text-to-speech feature is on.
Hello.
Now, the cool thing is that you can actually remove all of this by pulling down on that string. Now let's do ILY.
L.
As you can see, everything was appropriately taken in.
Eileen.
Now we can remove the last letter in the string by pulling up on the dialog box, as you can see. Now let's try adding back to that again. As you can see, that works as intended, and now you may add a space where, as long as anything is not being detected at the moment, a space will be implemented when you press the middle button. Let's add afterwards, and you see there's a space between IA, EE.
Let's discuss our testing plan. During the development of Project Insight, abiding by Agile's methods, many tests were created to ensure the stability of the development process and to ensure the final product functioned as intended. Model evaluation tests were consistently done to ascertain the efficiency and performance of our model as changes were made. Unit tests were carried out to test the main object classes utilized by our application. These automatic tests were carried out using JUnit 4 and ensured our application's basic functions were successful. Components testing was done according to the principles of mobile application testing. These tests were done to ensure concrete functionality of each core component and interface of the application. Through the iterations of the application, integration tests were consistently done to ensure that connections between units were well integrated, such that nothing would break during the development, and making it so that bugs would easily be discoverable and rectifiable. Upon completing the system, the integration of all components into the system was tested to ensure that the system is successful at meeting its various requirements. This was done by ensuring through the demo that our system was able to accomplish all our application's functional requirements. Finally, acceptance tests were carried out by identifying various scenarios which could help us ascertain the quality of our solution. Like an alpha testing phase, various activity flows were explored by the development team as well as selected alpha testers based on specified design points such as the use cases, user stories, architectural design, etc. These tests were especially significant at identifying faults in the system flow, thus allowing quick, high-priority fixes. These could be seen in the previously shown demonstration. Let's talk about the future of Project Insight. Even though we have accomplished our initial goals for Insight, there's always room for improvement and expansion. Some aspects which can possibly be upgraded or added to the application in the future include the model's prediction precision, such that our application can boost higher accuracy for translation. The dictionary can be expanded to include more signs. Expansion to full-scale action recognition, which can classify a wider range of movements. The ability for sentences to be autofilled, similarly to Google's Gboard suggestion fill feature. The integration of a call system which would make conversing with ASL-dependent individuals over far distances easier. This is the end of our presentation. A special thanks to our supervisor, Dr. VJ, for his guidance. Thanks for watching.